like a master node, the one that makes the organization of all the information. And you have a job tracker. Job tracker is related with how MapReduce is working, and the master node is related how the HDFS is working. We can have different nodes that are called slave nodes, and those slave nodes are called data nodes. And there is where the information is stored. Here, you use the master node to transfer the information, to say, for example, how to store this file. You say that to the master node, but the master node decides in which of all of these the information is stored. And each of all of these have the map and reduce operations, workers, that at the end make the operations that need to be done. Okay. And here we have also, I think you saw this slide in the previous session, but maybe in this one is starting to have sense about what is all of this one. For example, remember in the previous slide we have these layers. Each of these tools we have here are related with all of those layers. For example, you have the visualization engine. And for Hadoop, the visualization engine is Hue and Tableau. Tableau is the commercial one, it's expensive. And Hue is the one that comes with Cloudera. Maybe we are going to use that when we are going to work with Cloudera. Remember, we spoke about the storage. And in the storage, in the previous one, we were speaking about the distributed file systems. Here we have HDFS for that. Also, remember that we spoke about NoSQL. Here we have HBase, that is the one that is coming with Hadoop for NoSQL database. But also, you can have here MongoDB, Cassandra, the one that you can speak. Also, we was speaking about a data acquisition layer. We have here Scoop. Scoop is one tool from the Hadoop ecosystem that helps us to bring to our solution information coming from relational databases. So if you want to bring information from relational databases to HDFS, you can use Scoop. Remember that we spoke about event processing engine. In that case, we are speaking about Spark, because Spark is one tool that helps us to bring information coming from event source data. Yes. We spoke about the resource manager. That is the one that reserves the information, reserves the memory that are going to use our process, or reserve the disks that are going to use our process. Jar is the tool that is used for that. So the Hadoop ecosystem consists on a source of information that feed our layers in some way. I don't know if we have some space to resolve questions. I don't know if you want, if you have questions at this moment. Fault tolerance. Okay. let's say, for example, okay, for example, if you have one file and you want to store that file in the distributed file system, you send, for example, to the resource manager. You send that file, and this one decides that the data set will be stored here, will be stored here, and will be stored here. Yes? And here, there is a customer that wants to query that file. And this guy use a client to bring it to try to query that file. That client go to the distributed file system and decide that one node decide that the system will bring out my file and returns the file to the client that is trying to query information. But if in this moment there is a problem with this server and is not available, you have also the file in two different servers still. So the information is always available. That is why the system is fault tolerant. Because if you don't have the information available here, you have the information available here. Also, the Hadoop distributed file system, if it identifies that this node is not available, automatically takes this file and reply to another node to make available in three nodes. Also, if you configure that you want to have the information in 4 nodes, you will see your information in 4 nodes or in 6, or that depends. But that is why that is fault tolerance, because the information is guaranteed that is always available.
que tengo por debajo de la herramienta, pero igual que pero es que estoy corriendo un elementario por debajo. Pues esperemos a ver, porque pues está corriendo un poco más. Yo lo corro. 10 sigas. Aprovechar. Las que no hay en casa. Pero ya está puesto. DKMS de medias de DKMS. No, pegado. Eso tiene la parte de mes. DKMS y ya.
I want to show here this is a resource that is available in the Apache project page. In this resource, you will see that there is a list about the projects available for big data that are related with the Hadoop ecosystem. There are 14 projects that you can query about. And how you can, for example, identify in some moment what can help you. If you want to make, for example, some investigation about how to use some of them. In the market there, normally you will find in the market that are common projects. For example, these days, Spark is one of the most used frameworks. But always it's good to come here and see what is new, what you can study. For example, you can come here and say, for example, open the project and you will find one description. Then Apache Flume is distributed, reliable, and available system for collecting, aggregating, and moving large amount of log data. So the thing I want to show you here is that in the description you will find always information more or less related with the ledgers that we saw. So that way you will understand what is the use or how you can use that tool. For example, in this case, moving the keyword is moving large amount of log data. So we are speaking about the data acquisition ledger because it's moving large amount of data. And in that moment, we understand that it's a tool that we can use in the data acquisition ledger that we saw previously. For example, if we spoke about Apache Flink, open source system for expressive, declarative, fast, efficient data analysis. So we know that the Flink is a tool that we can use in the analysis ledger. It's very important to understand that it's not important to know all the projects. Maybe just know it's important for you to understand some aspects of each project, maybe the name, what each project do, because not all the projects, some projects comes to the light but not have successful. But in this case, for example, Apache Scoop, designed for transferring good data between Apache Hadoop and structured data source. So we are speaking about the acquisition layer there also. You can go to this page to query the projects available from Apache to work. Yes, Zeppelin is the one we are going to use in this practice, for example. It's a web-based tool for the data science to collaborate over large-scale data exploration and visualization projects. Then we have some data exploration. We are going to speak about data analysis ledger, and visualization ledger. In some moments we are going to use Apache Zeppelin also. And also in the next session you are going to use Apache Zeppelin. The other resource I have here to show you. If you, as I told you, you can in big data work, for example, as a data science, maybe making the analysis. You can work, for example, as a big data engineer. As a big data engineer, maybe you will have to deal with moving data, with storing data, with processing data. You can also look for the role as a big data architect. This page shows maybe some big data patterns because there is not just way to make one Apache, one big data project. For example, maybe you just want to consume information from different sources and make an analysis in a sandbox in the way we are going to make in the next part of the session. Or maybe you want to make the analysis, send that information to one data warehouse, for example. That is other kind of project. Or maybe consume the information and processing information to send the results to a visualization tool. There are several ways to design one project. There is no just one way to design one project, because there is not just one purpose. In this page, if you want, you can come here to say how can be implemented one project from the concepts, from the conceptual view. This is, for example, the one that we are going to use in some moments, because we are going to use one analytical samples, the samples that is out there. We don't have one way to bring the information out from there. And the message is that there can be a lot of ways to design one project in big data, and you, in your future, in your professional future, you can decide what role you can use in your career. You can be a data science, a big data engineer. There are a lot of roles that you can apply in that case. That is the message in this case. Also, if you want to go deeper in the concept of big data, there is an author, that is Thomas Earl. He's the guy who tried to bring down the concepts. A lot of them we saw here in a book that is called Fundamentals of Big Data. That is what you can use if you want to have one point of starting point for starting and go deeper in big data. And I don't know if we have another questions, or maybe we can.
It's a book, or
yeah, it's a book. It's a book. Thomas Earl is the author, and the book is called Fundamentals of Big Data. Okay. We can take the lights off. Yes. Because in this case, we are going to return to one. When we are speaking about NoSQL databases, when we are speaking about relational databases, we are speaking about just information that we have in tables, on the columns and rows design, yes, maybe with indexes. You can query that information easily, maybe with select all from some table. That is a way to query information. Maybe you can have consistency, because you can assure that information is not flexible. If you have the customer, you have the sales for that customer, and that's why you have related information. But in NoSQL, we have different data models. That is a very important concept. One NoSQL database can be of three different ways. For example, key value. When I have a key value database, I have, for example, just like one data lake, and I have data sets that I have identified I give one name. It's a key value. It's a key value concept. Yes, and you can access. For example, you can, or maybe I will check this. For example, you can have keys for each data set that you have. And you can say to the database, for example, I want to the object that you have in tree. and the NoSQL database returns this. But what is this? This can be one file, this can be one image, this can be one video, this can be one JSON. You can store what you want here. You don't.
So the main difference is that NoSQL databases can store unstructured information.
Yes, unstructured and non-structured, semi-structured information. That is the one main difference. But you don't also just have that way of key value, but you have also column-oriented table. For example, you can have one big table, and each row for that table is a record. Normally it's used in big data to join all the data together in a SQL database, in a relational database. Normally you try to normalize the information. That is an important concept. Normalize information. Normalized information is try to set apart the information that is common for each case. For example, you can have in one table the customers, in another table the addresses, in another table the sales. In big data, it's normal to join information together in a bunch of big data sets. You can have also maybe a million of columns in a data set. And you can also, for example, have a big table that, for example, have here the customer name and also customer sales. And here in customer sales, you can have, for example, store one PDF file. You cannot do that in a relational database. And also, you can have, for example, the picture of the customer. Yes? That is a column-oriented database. But also, the most used NoSQL database in my concept is the document-oriented, because it's a hierarchical way to store the information. You can, for example, MongoDB is one hierarchical database. You can store set information, the JSON files, or JSON information. You can, for example, if you are dealing with an Angular application, and you want to store your customer, the customer just registered in the Angular platform, and that information is converted automatically in a JSON file or in a JSON format. And using the API that we saw previously, we send the customers to NoSQL database in a natural way. You store the information as it's coming from the Angular, because you have one API that normally is a REST API to store the information in the NoSQL database. And you have here the JSON. And you can use different tools or clients to query that information, or use the same API to query that information. You can, if you have the customer have two addresses, you can say to the NoSQL database that you need one address, because as information is in the JSON, here we have the